Good morning. Today I will present a final of my project Seascape Serenity. Unfortunately, I'm not able to join you in Montreal today, so I have pre-recorded this presentation including a demonstration of my project. Here is our outline. First, we have the introduction to my project and have the methodology and adjustments. And third one, we have the implementation of my work and the demo and the future work. Here is the recap of our pipeline of Seascape Serenity. The process begins with the underwater recording, serving as the foundation of our project. Building upon the original work, we have transitioned from a static presentation to an interactive, real-time performance. By simulating echolocation, we aim to connect human interaction with marine bioacoustics, creating an immersive experiences that combine sound and visuals. So our methodology includes the electronic music and immersive audio, recontextualizing marine elements, and the third one is the echolocation simulation. So here is a review of my previous presentation. We want to complete the incorporation of radioscope data to enhance holographic displays, and also to develop an interactive enhancement of the user interaction elements to enrich the overall experiences. And the third one is to refining the echolocation simulation to continuously improve the simulation accuracy and realism. So for my adjustments, we have the user control simulation, which let all the participants can control the simulated whale movements using their smartphones, integrating the gesture and orientation data. The second one is the whale-centric interface, which incorporates the real-time visual and the sound design, enhancing the immersive experiences in two perspectives. The first one is the whale-centered view, and the second one is the object-centered view. The whale-centered view means that the user experiences the ocean from the whale's perspective and controlling its movement and interaction. And for the object-centered view, the user simulates the perspective of stationary objects of other marine animals and interact with the moving whale, offering a dynamic contrast in experiences. So move on to our user-controlled hologram. We gather the gyroscope data through a multi-sensor app, and the 3D whale motions are crafted using Touch Designer, with the design contribution of my friend, visual designer Xingyu. We explore how audience use their smartphone to control a simulated whale movements and sounds with our hologram display in real time. So for the visual interaction, which is the upper panel in blue, the multi-sensor app using the gyroscope sends the OSC, the Open Source Control data to Touch Designer, animating the whale movement in the hologram. And for the acoustic interaction, which is the lower panel, we use the multi-sensor app to send the gyroscope, the acceleration, and then through the OSC, then pass to the max NSP. The gyroscope data modulates the spatial parameters through the ear-conspat, adjusting the soundscape across the 12 speakers. Integration of the distance sensor to modify the click sound, enhancing the realism. And the last one, we have the ambient sound, that their background audio depends the immersive underwater environment. So this slide shows our echolocation simulation from two perspectives, which I mentioned in the former slide, the whale-centered view and the object-centered view. And the whale-centered view allows participants controlling a whale's movement through their smartphone. The object-centered view simulates the perspective of the static object or marine creatures as the whale approaches, illustrating the spatial interaction in marine environments. So for my demo, here is the patch setup of the multi-sensor integration, which we had the distance sensor part, the gyroscope part, the accelerometer part, and also the part that sent to the OSC to Touch Design, and in the 12 speaker. So this picture is the demo setup for my project. From left to right, we have the Mac computer, which manages all sound processing tasks using the Max NSP, including the spatial audio control. And the middle part is the hologram box, constructed from the phone card to ensure the durability and high-quality visual display. And the right part is the PC, another computer that runs Touch Designer to handle the visual simulation and synchronize with the hologram graphic output, data flow, and system integration. We capture the multi-sensor data from mobile devices, transmitting it through the OFC to the Mac for audio processing. And the audio data processed by Mac's NSP is sent to PC running Touch Designer through the OSC again, ensuring the real-time interaction and integration for the 3D holographic display. So for my future work, I want to build a web-based interface which transition to a web-based demo platform by using the Sensor API to replace the current app. So the users can access the simulation through the QR code scan, simplifying the entrance process. Also, implement more sophisticated visual mapping techniques and refine real-motion design to enhance realism and interaction. And the last one is to conduct user feedback survey to gather insights and improve our experiences based on the direct participants' responses. Thank you for your attention.